When we think of the most dangerous substances in the universe, antimatter is often top of the list. It's a substance made up of antiparticles, the counterparts to the matter that makes up everything we can see around us. When regular matter comes into contact with antimatter, the two annihilate each other, releasing tremendous amounts of energy. This makes antimatter a potential super powerful fuel source, also makes it potentially super dangerous. But there might be something even more dangerous out there, strange matter. And if these two were to somehow meet up, strange matter might just come out on top. To understand how this could be possible, let's first take a closer look at what antimatter actually is. As I said before, antimatter is made up of antiparticles. For every type of particle in the universe, there is an anti-counterpart. For example, the antiparticle of an electron is called a positron. It has the same mass as an electron, but a positive electric charge instead of a negative one. The same goes for other particles, like protons and neutrons. Their anti-counterparts are antiprotons and antineutrons. Now, when regular matter and antimatter meet, these particles annihilate each other because they're each other's matter. But when two particles of the same type of matter meet, like two protons, they don't automatically annihilate. So if you had a container full of antiprotons and antineutrons, those two types of particles would be able to come together and form a stable ball of antimatter. And since they're not annihilating each other, that means they're not releasing energy. So far, this is great for making a doomsday weapon. But to make a doomsday weapon, you need more than just a ball of antimatter. You need to contain it. Otherwise, the moment it touches regular matter, kaboom. Scientists have actually managed to contain antimatter using magnetic fields. Since antiparticles have the opposite charge to regular particles, you can use magnetic fields to keep them apart. By surrounding a magnetic field with supercooled alcohol vapor, scientists were actually able to trap a few antiatoms long enough to observe them. But while that's great for science, it doesn't really help us figure out who would win in a fight between antimatter and strange matter. That's because I haven't told you about strange matter yet. You see, there are even more types of matter out there beyond regular and antimatter. For example, quark matter. You may have heard of quarks before. They're the particles that make up protons and neutrons. There are different types of quarks, and it takes just the right combination to make a proton or a neutron. Normally, you never see a free quark floating around in space. That's because they have a particular habit of coming together and forming larger particles called mesons or baryons, which are held together by another type of particle called a gluon. Mesons are made up of a quark and an antiquark, while baryons are made up of three quarks. Protons and neutrons are examples of baryons. The reason this happens is because quarks have a particular habit of getting locked in together due to a property called color confinement. Think of it kind of like a three-way race where no one can overtake anyone else, so they all end up finishing together in a group. What's weird about quark matter is that, under certain circumstances, it becomes super dense and is able to exist in a state called quark-gluon plasma. In this state, the quarks and gluons are free to roam around inside the matter, which is unlike their normal behavior where they're confined together. Now, like antimatter, quark matter can be dangerous. A lot of particle accelerators actually use quark matter to simulate conditions that existed just after the Big Bang. This quark soup is so hot and dense that it behaves very differently from the way matter behaves now. In fact, it's thought that, at these high temperatures and densities, regular matter would actually turn into a quark soup as well. This means that if you took your regular old ball of antimatter and threw it into a big enough star, it might not just annihilate, but actually get turned into quark matter. At that point, the only thing that can stop it is more matter. So unless our heroes have a way to stop the flow of matter into the star, strange matter wins this round. Now that doesn't mean antimatter is useless. In fact, there's currently a $10 million reward for anyone who can create a working antimatter engine. So maybe one day antimatter will become a useful fuel source. Till then, though, strange matter wins. If you enjoyed this quick dive into the weird world of matter, you'll probably enjoy the rest of the videos on our channel. So click the subscribe button to stay updated on all our future videos.